A single freight train stretches 2.5 kilometers across open desert, carrying up to 22,000 tons of iron ore in 200 cars behind 4 diesel locomotives. The Mauritania Railway runs 700 kilometers through the Sahara from the mining complex at Zouérat to the Atlantic port of Nouadhibou, crossing terrain where summer ground temperatures exceed 60 degrees Celsius, where sand drifts bury track overnight, and where the nearest paved road lies hundreds of kilometers away. The engineering question isn't whether you can build a railroad in the desert, it's whether you can keep one running when every component, from ballast to brake shoes, must arrive by the same isolated line it's meant to maintain. Mauritania gained independence from France in 1960 with almost no industrial infrastructure and one exportable resource, high-grade hematite iron ore in the Kediet-Ijijil Massif near Zouérat. European steel demand was climbing, but the deposit sat in the interior, 650 kilometers from the nearest deep-water anchorage. Road haulage at that distance and tonnage wasn't commercially viable. The national government and a consortium of European steel companies formed MyFirma, the Mauritanian iron ore mining company, in 1963. The plan was direct: build a single-track standard-gauge railway from the mine to a new ore terminal at Nouadhibou, install crushing and loading equipment at both ends, and run the heaviest trains the line could handle. Construction began in 1960. The railway opened in 1963. On paper, it looked like a typical colonial mineral railway, the kind built across Australia, Canada, and Southern Africa whenever a remote deposit justified the capital cost. The Sahara imposed constraints that conventional mineral railroads never faced. Between Zouérat and Nouadhibou, the route crosses the Adrar Plateau, descends through the Guelb Richat geological structure, and runs west across gravel plains where seasonal floods can wash out embankments in hours. Daytime rail temperatures regularly reach 70 degrees Celsius, expanding steel enough to buckle track if expansion joints are spaced incorrectly. Sand infiltration is constant. Fine grains work into axle bearings, brake assemblies, and traction motors. Windblown dunes cover sections of track within a single night, requiring manual clearing before the next train can pass. There are no towns along the route. There is no grid power. There is no parallel road for road crews or emergency access. Every repair part, every liter of diesel, every replacement wheel set, and every ton of ballast must come in by rail or, in extreme cases, by air to the few desert landing strips maintained by the mining company. MyFirma adopted a solution that looked reckless by European standards: run fewer trains, but make each one as long and as heavy as possible. A standard loaded train today uses 4 General Motors or Alstom diesel-electric locomotives, pulls up to 210 ore cars, weighs up to 22,000 tons, and measures roughly 2.5 kilometers from the first locomotive coupler to the last car. Maximum authorized speed is 60 kilometers per hour on straight sections, far slower on curves and grades. The round trip from Nouadhibou to Zouérat and back takes roughly 30 hours, including loading and unloading. One train departs the port each day. One loaded train departs the mine each day. By concentrating all tonnage into a single daily service, the railway reduces the number of crew shifts, the wear cycles on switches and crossings, and the diesel fuel consumption per ton of ore delivered. That operating model creates a maintenance paradox. Because only one train runs in each direction per day, any mechanical failure or track obstruction halts the entire export operation. There is no redundant line. There is no alternative route. If the daily loaded train breaks down halfway between Zouérat and Nouadhibou, repair crews and replacement parts must travel up to 350 kilometers by rail or off-road vehicle to reach the site. If sand drifts block the track during the night, work gangs must clear it before the next departure or the entire schedule slips. The railway employs track maintenance teams housed in small camps along the route, equipped with diesel speeders, hand tools, and limited spare rail sections. These teams patrol assigned sections daily, clearing sand, tightening bolts, and replacing worn components before they fail. The system depends on predictive maintenance and local autonomy because centralized dispatch cannot respond quickly enough across 700 kilometers of desert. The second constraint is passenger safety and revenue. Mauritania has no other long-distance public transport linking the interior mining towns to the coast. The railway officially prohibits passengers from riding in ore cars, but enforcement is minimal and tickets are not sold. Travelers, including workers commuting between Nouadhibou and Zouérat, routinely climb into empty ore cars on the return leg from the port. These cars offer no seating, no weather protection, and no sanitation. Riders bring their own water, food, and blankets. The journey takes 12 to 18 hours depending on delays. One or two passenger carriages are occasionally coupled behind the ore cars, offering seats and a roof, but these are infrequent and the service is informal. The railway's primary function is ore haulage. Passenger transport exists because the line is there, not because it was designed for people. Operational costs remain high. Diesel fuel must be trucked to Zouérat and Nouadhibou from coastal depots or imported directly by ship. Locomotive maintenance requires specialized technicians and imported parts. Or car wheel sets wear quickly under heavy loads and abrasive dust, and replacement wheel sets must be shipped from overseas suppliers. The railway operates as a state-owned enterprise under SNIM, the National Industrial and Mining Company, which succeeded my firma after nationalization in 1974. SNIM controls the mines, the railway, and the port, allowing it to optimize loading schedules and allocate maintenance budgets across the entire supply chain. Annual iron ore exports through Nouadhibou fluctuate with global steel prices, but the railway typically moves between 10 and 12 million tons per year. That volume justifies the infrastructure cost, but leaves little margin for prolonged downtime or major capital upgrades. The railway's isolation has made it a subject of travel documentaries and engineering case studies. Michael Palin rode the train during his 2002 BBC series Sahara with Michael Palin, documenting the experience of traveling in an open ore car. Other journalists and photographers have since repeated the journey, drawn by the visual scale of the train and the starkness of the landscape. These accounts emphasize the physical discomfort and the sense of remoteness, but they rarely explain the operational decisions that make the railway economically viable. The train is long and slow, not because Mauritanian engineers lacked better options, but because concentrating tonnage into fewer departures minimizes crew costs, fuel consumption, and track wear in an environment where every component must be imported and every breakdown halts the entire export chain. Today, the Mauritania Railway remains one of the longest and heaviest single trains in regular service anywhere in the world. It continues to operate with minimal changes to its original 1963 design: standard gauge, diesel traction, single track, passing loops at fixed intervals, and a daily schedule dictated by the time required to load 22,000 tons of ore at Zouérat and unload it at Nouadhibou. Proposals to upgrade the line with heavier rail, more powerful locomotives, or double tracking have not been implemented, largely because the existing system already moves the volume of ore that current mining and port capacity can handle. The engineering lesson is not that extreme trains require extreme technology, it's that extreme environments demand extreme operational discipline. In the Sahara, the train runs because it has to, and it survives because every person along the line knows there is no backup plan. Visual reconstructions are illustrative. Facts and interpretations are based on the sources listed in the description.